All right, guys. Today we're talking about area and sector area of circles. It's 11.2. Just to refresh real quick on a couple of circle terms. First off, the R usually stands for the radius on a circle, and it means the distance from the center to the edge of the circle or halfway across the circle. So that's one important thing to know. The other important thing to know would be that D stands for diameter. And that would be the entire way across a circle through the center. All right, and the diameter is twice the radius. So if the diameter is 10, the radius will be 5. If the radius is 7, the diameter would be 14. So we talked a bit about that relationship yesterday when we were talking about circumference. So continuing on today, we're going to talk about area of a circle first. You might have heard this formula before. It is pi r squared. So pi times the radius squared. So for our first example, we'll do one where we're given a picture of a circle like that. And this is 10 inches. All right. So the first thing we have to ask ourselves is, have we been given the diameter or the radius? In this case, we've been given the diameter, which is 10. And in order to find the area, I need the radius because my formula includes the radius. So we're going to find radius, half the diameter, so the radius is 5. So now we're ready to go with our area formula. Area is pi times the radius squared, so pi times 5 squared. And the first thing that you want to do is square the radius because we have to follow the order of operations. Exponents comes before multiplication. So 5 times 5 is 25. 25 pi is one way that we can write our answer. 25 pi inches. This would be considered exact form. So yesterday we talked a little bit about exact form versus a rounded decimal. Sometimes you'll be asked for one or the other. Typically, if you're going to use this measurement to estimate or something, you'll want the rounded decimal just because that's an easier number to like actually visualize and stuff like that. I don't know what 25 pi inches looks like, but if I type it into my calculator, I might be able to visualize what 78.5 inches looks like, which is what that is if we type that into our calculator and round to the nearest tenth. So this would be our rounded answer. And again, these are both fine and would be correct in different circumstances, depending on what you're asked for in the question. So that's finding area. Why don't you go ahead and try one? Here's a circle. I'm going to say that is 7 centimeters. So watch out. This time you were given a radius right away. Pause the video for a second, give it a try, and then restart the video once you think you have it, and we'll go over it. All right. Hopefully you paused it, gave it a go. And let's check our answer here. So in this case, we have 7 centimeters is the radius. So we can just go pi times 7 squared. 7 squared, 7 times 7 is 49. So 49 pi would be our exact answer. But if we typed it into our calculator, we could also get a rounded decimal. If we went 49 times pi, we get 153.9. So those are two possible representations of our answer. Both are correct. One's exact, one's rounded. All right. So that's area, hopefully fairly straightforward. Sector area is the next thing we're going to try. So sector area, kind of like arc length yesterday, is visually, if we have a circle, maybe I only want to know about the area of one slice of the circle. Let's say I just want to know the area of that slice. Well, I need a little bit more information. I need to know either the radius or the diameter like usual, but I also need to know what this angle is of the slice that I'm looking for. Usually in formulas and stuff like that, you represent that with the letter theta. It's usually in degrees, but it could be in radians if you're in like an advanced algebra trig or a pre-calculus class. But since we're in geometry, we're going to use degrees. So our sector area formula is theta divided by 360, because that tells us about the fraction of our circle that we're looking for, times pi r squared. So we're basically taking the area and multiplying by the fraction of the circle that we have. So let's give it a go. Here's our circle. Let's say that this angle here is 275 degrees. And this measurement is 11 feet. I'll zoom in a little bit here. All right. So this time we have a big angle, 275 degrees. We have 11 feet. So collecting information for our problem, theta is 275 degrees. The radius is 11 feet. Now we're going to put this into our formula. So our sector area is going to be 275 over 360. So that's how much of the circle that we have, times pi times 11 squared, since 11 is our radius. All right, and we can type that all into the calculator just the way that it is. So I can type in 275 divided by pi times 11 squared, just like that. And it'll give me the whole thing. If you wanted to be careful or something, or you weren't sure on typing it into your calculator, you could square the 11 first and get 275 over, oops, gosh, I typed it wrong. I thought that answer seemed a little bit big. I didn't put in my 360. Goodness. Let's try that again. 275 divided by 360 times pi times 11 squared. That's better. Okay. But like I said, if you wanted to be extra careful that you were typing it incorrectly and you weren't so sure about this 11 squared part, you could go 275 over 360 times pi times 121, since that's what 11 squared is. Either way, we should get 290.4 if we round to the nearest tenth. Give it a try typing it into your calculator real quick. Make sure you feel comfortable finding everything and stuff like that. If you're not sure where your pi button is, see if you can find that. On most of the little scientific calculators, it's its own button. Then pause, or not pause the video yet. You guys are going to try one. Once I put it up here, then pause the video and try it on your own. So here's your circle. This time we'll say you're dealing with an angle that is 110 degrees. And this distance here is 9 inches. All right, find the area of this sector. Pause the video, give it a go, then keep it going again, and we will talk about it. All right, hopefully you paused and got a chance to give it a try on your own. Here's what would happen, or here's how you should do it. So again, on this one, theta is 110 degrees. So 110 divided by 360 times pi times 9 squared, since 9 is the radius. So 110 divided by 360 times pi times 9 squared gives us about 77.8 if we round to the nearest tenth. So 77.8 inches. Oh, and goodness. Since we're talking area, my units should all be inches squared and feet squared and stuff like that. Sorry, guys. So if we go back up to these ones real quick as well, we should have centimeters squared and inches squared. All right. So yeah, all of these should be squared units. Just like we were doing in the area unit last week. Okay. So those are kind of the simpler versions of the problems, right? Because you're just taking radius and sometimes an angle and plugging it into a formula. But now let's step it up just a little bit and work kind of backwards, finding diameter or radius given the area. So for this first one, we're going to be told the area is, let's see, 36 pi square feet. And we want to find diameter. Okay. So first off, we know area equals pi r squared. You might even already be able to tell what the radius or the diameter might be from this one. But we're going to take 36 pi and we're going to put it equal to pi r squared. The first step is going to be to divide by pi on both sides, just like it was when we were doing circumference to find diameter and radius yesterday. Divide by pi first. In this case, since there's pi on both sides, it cancels out on both sides. So we're left with 36 equals r squared. Then, since we have r squared, we have to square root both sides. The square root of 36 is 6. So we get 6 for the radius, but we were asked for the diameter. So now my last step is to multiply by 2 to get 12 for the diameter. So the diameter is going to be 12 feet. All right, there you go. Now you can see it. All right, so that's one kind of problem that you might see given area trying to find diameter. And that's the case where it was left in exact form where you've got the pi in your answer or in your area. Next time, for our next example, we're going to say the area is 156 square centimeters. And we are going to find radius. All right, so finding radius, area is 156 centimeters squared. We set it up the exact same way that we set up the last one. We go 156 equals pi r squared. And we start off the same process even. We divide by pi on both sides. But 156 divided by pi isn't really like a nice number to work with here. We're going to leave it like that just for a moment, though, because the next step we're going to end up putting stuff into our calculator. So let's rewrite this as 156 divided by pi just for a moment equals r squared. So if we do that, the next thing that we would do is square root both sides. And then this is something that I can type into my calculator, the square root of 156 divided by pi. So let's do that. Calculator, second button, square root 156 divided by pi. We get 7.046. So if I was rounding to the nearest tenth, because this will be my final answer, we get approximately 7.0 or just 7 centimeters for our radius. All right. So on this one, we don't always get a nice number answer that's like a whole number or doesn't involve any decimal at all. In fact, a lot of times you're going to end up with decimal answers, and that's okay. Just what I would do is save the square root in the calculator step for the very end. All right. So now it's your turn to try one. One last problem here. This time, I'm going to tell you area is 227 square meters. And I want you to find diameter. So pause the video for a second, give it a try, and then hit play again, and we'll talk about it. All right, hopefully you paused it and tried it on your own. Let's see how it's done. Same process as the last one, just one extra step at the end. So 227 equals pi r squared. Divide pi on both sides. And we're left with 227 divided by pi equals r squared. Square root on both sides. Stick this into your calculator, but we didn't want just the radius, we also wanted the diameter. So once you find the radius by using your calculator, we're going to go square root 227 divided by pi. We get about 8.5. Maybe keep a few extra decimal places just in case, since it's not our final answer. Then what I want to do is times 2 to get diameter. And you can do that right in your calculator. You can just hit times 2 and it'll save it and keep going for you. So we get 17.0. So 17 meters is our diameter. And then we're good to go. All right. So hopefully this was helpful. The next couple of pages here have your homework assignments. Let's take a look at that as well. All right. Numbers 1 and 2, you're finding the area of each of these and rounding to the nearest tenth. Numbers 3, 4, 5, and 6, you're finding the area in exact form. So leave the pi in your answer. For 7 and 8, you're finding the area of the sector, rounding to the nearest tenth. On the next page, 9 and 10 have the same instructions as 7 and 8. So keep that going. 11 and 12, you can cross off exact form and keep the same instructions as 7, 8. So 7, 8, 9, 10, 11, and 12, find the area of the sector, round to the nearest tenth. Then 13 and 14, find the radius given the area. So this is just like the last example that we did, or the last couple of examples. Round your answers to the nearest tenth. And then the same thing on 15 and 16, except you're finding the diameter this time. So that was just like the one that we did last. You have the area, find the diameter. All right, have fun. And I'll see you guys later.